Hello students, I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our series on triangles for class 10 student. Note that this complete series is as per the latest updated syllabus, and in this complete series we will cover all these chapters using the power of animation and the visual tool to make the tough concept easier for you. In this lecture we will cover exercise 6.2 question 1 to 5, and the link to all the lectures is given in the description. Check it out. And students, one important thing, do not forget to download the PDF of the concept and formula list. The link is given in the description. That will be really helpful to solve the question and also brush up the concept whenever you are having the exam or whenever you need so. So without taking any further time, let's start with this lecture. Best of luck. Let's start with question number 1. Question number 1 is, in figure 6.17, 1 and 2, DE is parallel to BC. Find EC in 1 and AD in 2. Here we are having two parts of this question. Let's take the first part. Firstly, let's observe the figure. In the figure, a triangle ABC is given, and in this triangle, the line segment DE is given as parallel to BC, that is the side of the triangle ABC. So DE and BC are parallel to each other, so we can apply the BPT theorem here. In the BPT theorem, if these two lines are parallel to each other, then the ratio AD upon DB will be equal to the ratio AE upon EC. So we got AD upon DB is equal to AE upon EC. In the figure, AD is given as 1.5 cm, DB is given as 3 cm, AE is given as 1 cm, and we have to find the missing dimension EC. We can simply put the value in the equation. We got 1.5 upon 3 is equal to 1 upon EC. On solving, we got the value of EC as 2 cm. We got the part 1. Let's take down the part 2. In the part 2, again a triangle ABC is given, and further the DE is given as parallel to BC. So DE and BC, these two line segments are parallel to each other. So again we can use the BPT theorem, but here AD is missing. We know DB as 7.2 cm, AB as 1.8 cm, and EC as 5.4 cm. AD is missing in this part. So we can apply the BPT theorem because DE and BC are parallel to each other. We got AD upon DB is equal to AE upon EC as per the BPT theorem. Let's put the given value. On solving, we got AD as 2.4 cm. The simple mathematical calculation. So we got our answer as 2.4 cm. So we have solved for part 1 and part 2. Okay. Before moving to the next question, let's again observe both the figures. And we will try to find the answer without touching the pen or the pencil. Firstly, let's observe the first figure. In the first figure, if you observe the line segment AB or the side AB, here AD is 1.5 and BD is twice of AD, that is 3 cm. 1.5 and twice of 1.5, it is 3 cm. So DB is twice of AD. As per the BPT, the ratio of left hand side will be equal to ratio of right hand side. That is the ratio of AB in which AB is divided will be equal to the ratio in which AC is divided. So on AC side also it will be double. Like AE is 1, then EC will be twice of 1, that is 2 cm. Got it? In the ratio term, on the left hand side the ratio is 1:2. So on the right hand side also the ratio will be 1/2. AE is 1 cm, so EC will be twice of AE, that is 2 cm. Got it? Similarly, let's apply the same concept on the figure 2. If you observe AC, the right hand side of the triangle, here 1.8 cm and 5.4 cm are given. Basically 5.4 cm is 3 times of 1.8 cm. Or in other words, we can also say 1.8 is 1/3 of 5.4 cm. Same philosophy we will apply on the left hand side because here BPT is applicable. So both sides the ratio will be equal. So here also AD will be 1/3 of DB, which is given as 7.2. So what is 1/3 of 7.2? It is 2.4 centimeter. So here the ratio is 1:3. The topmost portion is 1 and the bottom portion is 3 times of the topmost portion. Got it? So my point is that just by visually looking the question, looking the figure, you can mentally solve the question. Rest you can simply apply the simple mathematics on the paper. 90% you can solve in your mind. So this is the power of visualization. You should able to observe the figure in very detail. So let's move to next question. E and F are point on the side PQ and PR respectively of a triangle PQR. For each of the following case, state whether EF is parallel to QR. So we are having the three part, we will take one by one. In this question, a triangle PQR is given and PQ and PR are having the point E and F. Point E on PQ side and point F on PR side. The dimension of PE, EQ, PF and FR, that is all the four parts are given in this question. We have to check whether the line segment EF and the line segment QR will be parallel or not. So what is the criteria in which EF and QR will be parallel or not? The criteria is the BPT theorem or the converse of the BPT theorem, the 6.2, in which if the ratio of PE upon EQ is equal to PF upon FR, then we can say these two line segments are parallel to each other. So we will check the ratio in all the three parts, and if the ratio are equal, then we can say EF and QR are parallel to each other. So in the first part, let's calculate this ratio. Here we know PE as 3.9, EQ as 3, PF as 3.6 and FR as 2.4. So firstly, let's find PE upon EQ. That will be 3.9 upon 3, which will be 1.3 upon 1, basically 1.3. Further, BF upon FR is equal to 3.6 upon 2.4, which is 3 upon 2. Here this ratio is not matching. That is, left hand side is not equal to right hand side. So here EF and QR are not parallel to each other. Got it? If this ratio is equal, then only EF and QR will be parallel to each other. The BPT converse theorem 6.2. Let's take the second part. Here also PE, QE, PF and RF are given. So we will use the same philosophy. We will check this ratio is equal or not. Let's find PE upon EQ, which is basically 4 upon 4.5, which is 8 by 9. Okay, we have removed the point. It is 8 by 9. Let's find PF upon FR, which will be 8 upon 9. So basically we got left hand side is equal to right hand side, that is BPT ratio is matching. So we can say EF is parallel to QR. Got it? This ratio is matching, so these two line segments will be parallel to each other. Further, let's take the third part. Here PQ is given as 1.28 centimeter, that is complete side of the triangle is given as 1.28 centimeter. And the other side of the triangle, that is PR, is also given as 2.56 centimeter. PE is given as 0.18 and PF is given as 0.36. Here we have to calculate EQ and FR before proceeding to the ratio. Let's do it. EQ will be 1.28 minus 0.18, that will be 1.10. And FR will be 2.56 minus 0.36, that is 2.20. So we got all the four line segment. Now we can check the BPT ratio. Let's find PE upon EQ. That will be 0.18 upon 1.10. On solving, we got the value as 9 upon 55. Okay, simple mathematics. Next, let's find PF upon FR. That will be 0.36 upon 2.20, which is also 9 upon 55. Our left hand side and right hand side are both equal to each other. So we can say EF and QR are parallel to each other. Got it? Simple. Let's move to question number 3. In figure 6.18, If LM is parallel to CB and LN is parallel to CD, prove that AM upon AB is equal to AN upon AD. Firstly, let's observe the figure. In this figure, LM and CB are given as parallel to each other. These two line segments are parallel. And LN and CD are also given as parallel to each other. And we have to prove AM upon AB is equal to AN upon AD. Okay. In the theory part, we have discussed that while taking the question, we will learn how to draw a triangle around the parallel line, then how to apply the BPT theorem. So this is the case. Here LM and CB are parallel to each other. Can you draw a triangle, or you can identify a triangle around these two parallel lines in relation to the concept of the BPT? Yes, we can find a triangle. The triangle will be ABC. If you observe this triangle ABC, here these two line segments are parallel to each other and BC will be the side of the triangle. So we can apply the BPT theorem in this triangle ABC as LM and CB are parallel to each other. Got it? Similarly here LN and CD are parallel to each other. Can you identify or observe a triangle around these two parallel lines? Yes, the applicable triangle will be triangle ACD. So in this triangle, the LN and CD are parallel to each other, so we can apply the BPT theorem. Let's see. Firstly, let's take the triangle ABC. In this triangle, we can apply the BPT. We got AL upon LC is equal to AM upon MB. Okay. Similarly, if we apply the BPT in the triangle ACD, we got AN upon ND is equal to AL upon LC. So we got two equations and both of the triangle are sharing the common side as AC. So the ratio AL upon LC will be common in both the equation. So here this and this are common. So we can equate both the equation and we got AM upon MB is equal to AN upon ND. Got it? AL upon LC is common in both the equation, so we can equate the remaining two terms. So we got this equation. Can we rewrite AM upon MB as MB upon AM and AN upon ND as ND upon AN? Yes, we can do so. We have just inversed the equation. Replace the numerator with denominator and denominator with numerator. By doing the cross multiplication, we can do so. So we got MB upon AM is equal to ND upon AN. Let's add 1 on both the side. Here MB and AM will be the complete length AB and ND and AN will be the complete length AD. Got it? So we got the equation as AB upon AM is equal to AD upon AN. Can we again inverse this equation? That is, we got AM upon AB is equal to AN upon AD. That is the answer. That is the proof we are looking for. The same thing we have done also in the example question in the previous lecture, where we have explained or where we have observed how we can add this +1 and do this inverse calculation to get our result. Okay, so the same question is also applicable here also. So we have done with this question. Let's move to question number 4. In figure 6.19, DE is parallel to AC and DF is parallel to AE. Prove that BF upon FE is equal to BE upon EC. Firstly, as per our standard rule, we will observe the figure and observe the question. In the figure, DE and AC are given as parallel to each other. That is, these two line segments are parallel to each other. And also DF and AE are also given as parallel to each other. Okay, these are the two line segments. Further, we have to prove that BF upon FE is equal to BE upon EC. So let's proceed with this question. Firstly, we will identify the triangle around the parallel lines. Here DE and AC are the parallel line. So are you able to observe any triangle around these two parallel lines? Yes, this big triangle ABC triangle is around these two parallel lines. So we got this triangle, these two lines are parallel. So we can apply the BPT theorem that will be BE upon EC is equal to BD upon DA. Okay, the simple BPT theorem we have applied. Further, the next parallel segments are given as DF and AE. So can you observe a triangle around these two parallel lines? Yes, this triangle we can identify in which DF and AE are parallel to each other. So we can apply the BPT in this triangle. We got BF upon FV is equal to BD upon DA. In both of this triangle, the line segment AB or the side AB is common. So its ratio will also be common in both the equation. That is BD upon DA. So BD upon DA is coming in both of this equation. So we can compare both of this equation and we can say BF upon FE is equal to BE upon EC. That is the answer we are looking for. So the questions on the BPT theorem is basically all about your imagination. Are you able to imagine the parallel line and the triangle around those parallel lines? Just follow the first step, identify the parallel lines, and around the parallel lines try to identify or observe the triangle. You will surely get a triangle. Next step, apply the BPT theorem. Further, the simple mathematics will solve your question. So we have done with question number 4. Let's move to question number 5. In figure 6.20, DE is parallel to OQ and DF is parallel to OR. Show that EF and QR are parallel to each other. So let's observe the given figure. Here ED and QO is given as parallel and DF and OR are also given as parallel to each other. Firstly, let's take ED and QO. Again, we got two parallel line segment. Can you observe and identify the triangle around ED and QO? Yes, we got the triangle PQO. This is a triangle. We can apply the BPT as ED and QO are parallel to each other. We got PE upon EQ is equal to PD upon DO. Further, let's move to the next parallel line segment, that is DF and OR. So observe the triangle or identify the triangle around these two parallel lines. The triangle is POR. So we can apply the BPT theorem here. We got PD upon DO is equal to PF upon FR. Got it? The simple BPT theorem we have applied. The ratios will be equal. These two triangles are sharing the common side PO. So the ratio PD upon DO, that is the ratio of PO, will be common in both the equation or common in both the triangles. So we can equate both the triangles or both the equations. We got PE upon EQ is equal to PF upon FR. Got it? Further, let's dim all the unnecessary part. Here we got PE upon EQ is equal to PF upon FR. If you observe the triangle PQR, this big triangle, here can we apply the inverse of the BPT? That is, if these two ratios are equal, so EF and QR will be parallel to each other. We have simply applied the converse of the BPT in the triangle PQR. So we got EF is parallel to QR, which is the answer of this question. Got it? Simply, we have again used the same philosophy. We have identified the parallel line and around the parallel line, we have identified the triangle. So students, we have done with this lecture. Hope you have enjoyed the lecture created using the power of visualization, our unique way of teaching. And do not forget to download the formula and the concept list. The link is given in the description. And also this series or this lecture is part of the complete series on the triangle. The link to all other videos are given in the description. Also check it out. So thank you very much for being with CREATA Classes. Have a great day and meet you in the next lecture. Bye for now.